Alright, today we're going to take a very quick look at the atomic structure of atoms, and we're going to use aluminum as our example. So you've had a piece of aluminum foil there in front of you here in class, and we've been using that as our example today. And so we're going to take some notes, and I'm going to show you exactly how the periodic table can tell us lots of information about elements and about the atoms that make up those elements. So this is all called the atomic structure. So in your notes, chemistry, a study of matter, picking up where we left off yesterday, after we talked about the protons, electrons, and neutrons that make up the structure of an atom. We're going to add to those notes very specific information about how many of each of those particles there are within an element. So let's go ahead and start. You should have your notes titled Atomic Structure. And we're going to very quickly go through these. So let's go ahead. We've been talking about aluminum, and here is the periodic table again that you're going to start using today to look some stuff up. And so we look on the periodic table, and we can find aluminum right here, Al. So I click on it, and here's aluminum, and it tells us some information right here, and this is what we're going to use today for our notes. It's this information about aluminum. Before we start our notes, what I'd like for you guys to do is list on your paper right now, go ahead and write this down, list some physical properties of aluminum, and I would like for you to try to list as many physical properties that you can think of for that piece of aluminum you have right there in front of you. So I'm going to give you a minute here or so and list as many as you can. Let's see what you guys got. So we're going to take a look at the actual physical properties of aluminum that exist. If you have any of these properties, then just leave it alone. But if you do not have one of them, I'd like you to add it to your list. And then anything, of course, that I do not mention on here, please cross off and just stick with these physical properties that I'm going to show you. It's just kind of a recap. We've already talked about physical properties, but it's always a good idea to keep in mind that all elements do have physical properties. So the first thing you probably noticed about aluminum is that its color is silver. If you used a different color, that's alright. Just change it to silver. Let's use that color to describe it. You also might have noticed that the aluminum is very lightweight as far as its mass is concerned. It is not very heavy. Another physical property of aluminum is it's very smooth, so its texture to the touch. Now, of course, you can take aluminum, and if you wad it up, it can start to feel more rough. But in general, aluminum in the form we typically see it is smooth. Which makes aluminum very malleable. Obviously, you've probably already sat there and you've bended and shaped it And you notice this with not only aluminum foil, but also with soda cans, very easily moved and shaped and crushed. That makes them malleable. Something we might not have thought of is that aluminum foil is reflective. If you were to shine a light on aluminum, the light will reflect off of there. Aluminum is also very strong. You might not think of that because you're thinking, well, I can rip it pretty easy, or I can crush a can pretty easy. But in general, aluminum, and especially when you combine it with other metals, it becomes very strong. Aluminum is actually used in the building of planes, so of airplanes. So of course, when combined with other metals, it can be a very strong metal. And finally, aluminum is non-toxic. Have you guys thought about this or not? But a lot of times we wrap food in aluminum, and aluminum foil specifically, and we're still able to eat that food. It doesn't harm us in any way, so it is non-toxic. That's another property of aluminum. All right, so we've got those. Add those to your list if you didn't have them, and cross out any ones that we didn't mention here. And let's go ahead and get to the main thing about our notes today. Whenever we click on aluminum on the periodic table, or if you just look it up in the book, this is what you're going to see. And so here's our notes that we're going to write down. The first easiest things to notice about aluminum is right here. Is its name. So I guess what I need you guys to do is first, over here on the left side of the screen, on your notes, I'd like you to go ahead and draw this really quick. Make it rather large. Don't make it small because we're going to add quite a bit of stuff over here. So go ahead on your notes and make yourself a big box. Put a 13 at the top, a capital A, lowercase l. Write the word aluminum and put 26.98 at the bottom. So that should be some time there, enough for you to make your quick aluminum as you would find it on the periodic table, and go ahead and write down here, as I already did, that obviously this is in reference to the name of the element. The other most basic thing you'll see on the periodic table is right here, and this is the symbol. All elements have a symbol. Not all symbols necessarily have the same letters that go along with the name of the element, and that's because a lot of the elements are named after their Latin names, and so therefore the Latin name given them is not the same as we use in English, and so therefore some of the symbols will be different. But all symbols are written the same. If it's just one symbol, like with carbon, let's go back up really quick and just take a quick look. If it's symbols of things like carbon, you'll notice it's just a capital C. So if it's one letter, it's that first letter is always capitalized. Another example is nitrogen, just a capital N, or boron, which is a capital B. But whenever we get into elements that have two letters, let's use helium as an example, they always capitalize the first letter, and the second letter is always lowercase. So there's helium. We could do another one with lithium, capital L, lowercase I. Here's chlorine, capital C, lowercase l. And the same is true with aluminum, capital A, lowercase l. So going back to our notes, notice that aluminum is a capital A, lowercase l. So you'll always see those. That's very common. Those two are very easy. Let's get into the other two parts right here, this 13, and down here this 26.98. And this is going to be how you do your assignment today, so please make sure you're paying specific attention here. This top number right here, which all elements in the periodic table have, this is called the atomic number. Atomic number. The atomic number tells us two things. The first thing the atomic number tells us is the number of protons. So whenever you're looking at these symbols of elements on the periodic table, you look at the number at the top, right there, 13. This tells us that aluminum has 13 protons. The other thing that it tells us is that aluminum also has 13 electrons. Remember our story from yesterday, positive Paul and negative Nancy, opposites attract, they get along. In order to get along, they've got to be the exact same amount of them. So if there's 13 protons, there's going to be 13 electrons. So very simple. The atomic number tells us both the number of protons and electrons. It's always located at the top of the symbol for the element you'll find on the periodic table. The last thing we got is right down here, this 26.98, and this will be different. Just like the atomic number is different for every single element, this number down here is always different for every single element, and this is called the mass number. Mass, we always think of weight, so this lets us know the mass of the element. This is the mass number. The mass number will tell us the number of protons and electrons combined. So you got to think, well, where are the protons, protons and neutrons, neutrons combined. So where are the protons and neutrons? Well, they're both in the nucleus of the atom, so this is telling us pretty much the mass of the nucleus protons and neutrons. So the mass number tells us how many protons and neutrons there are together. And so this is where you have to do just a little bit of math to figure out an answer. Since we know the top number tells us the number of protons, 13, and this down here tells us the number of protons and neutrons together, all we have to do is a little bit of math and we can figure out how many neutrons there are. So if there are protons, if they equal 13, electrons equal 13. To figure out how many neutrons there are, just do this here. Let's do a little bit of math. I'm going to take the mass number, which is 27, and go ahead and round it. And I'm going to subtract the number of protons, which is 13. So doing some quick math here, that means that there are 14 neutrons. Now you know how to use the elements on the periodic table, and so we have an assignment, and you're going to figure out how many protons, electrons, and neutrons several different elements on the periodic table have, and that will be your assignment for today. That assignment will be due Friday. Please go ahead and log it on your orange sheet of paper in the back of your appendix. Again, it will be due Friday the 28th. Please go ahead and log that.